Go. A measure of variability is a single value used to describe how spread out a set of data values are. The mean absolute deviation is a measure of variability. So that's what we did yesterday. It just shows how spread out the data is. Okay, so let's do this problem. Put your finger on in gym class. Ready, go. In gym class, the students recorded how far they could jump. The data set below gives the distances in inches that Manuel jumped. What is the mean absolute deviation of the data set? Okay, this is what we did yesterday. All right. So it doesn't tell me what the mean is on this one, so I have to find it. So let's get out your calculators. You're going to add 54 plus 58 plus 56 plus 59 plus 60 plus 55. How many numbers do I have total? 6. So, what is 54 plus 58 plus 56 plus 59 plus 60 plus 55? 342 divided by 6. 57. So my mean of those numbers is what? 57. So now I'm going to take that mean and I'm going to subtract the original numbers. So, or not subtract, but just how the distance between. What is the distance between 54 and 57? Say it. What's the difference between 58 and 57? What's the difference between 56 and 57? 59 and 57.
2.
60 and 57.
3.
55 and 57. 2. So now let's add all those together. So 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So now I have 12. And how many numbers do I have total? 1, 2, 3, 4, 5, and 6. So 12 divided by 6 is 2. So my mean absolute deviation is 2. So it's spread out. So what it's saying is the spread in between numbers, the average spread in between numbers is 2. And if I looked up there, is that kind of true? Okay. 56 between 58 is 2. So the average is 2. Okay. All right. Next page. So another measure of variability is called an interquartile range. So let's put our finger on range and let's read. Ready? Go. Range is the difference between the greatest value and the least value in a data set. Interquartile range is the difference between the upper quartile and the lower quartile of the data set. Range and interquartile range are also measures of variability. Okay, so let's read this example. Put your finger on it. Ready, go. The box plot shows the price in dollars of the handheld game players at 2 different electronics stores. Find the range and interquartile range for each data set. Then compare the variability of prices of the handheld game players at the 2 stores. Okay. So, all right, I need to calculate the range. So what is the range? Let's say our little rhyme. Okay, go. Hey diddle diddle, the median's in the middle. You add and divide for the mean. The mode is the one that occurs the most, and the range is the difference between. So what's the range? The highest number and the lowest number. So my highest number is 150, and my lowest number is 24. So let's do that real quick. 150 minus 24. What do you get? 126. So the range for store A is 126. Okay. Let's find the range for store B. So my highest number is 120. My lowest number is what? 30. Because it's right here. It's the lowest. Remember, it's the whisker. Okay, so what's 120 minus 30? 90. So the range for store B is 90. So the difference between the highest price and the lowest price is 90. Okay, now we're going to find the interquartile range. Now the interquartile range is you take the upper quartile and subtract the lower quartile. All right, so what's my upper quartile? 72, and my lower one is 48. So quickly, what's 72 minus 48? All right, what do you got? Say it loud. 24. Okay, so the interquartile range for store A is 24. All right, let's find the interquartile range for store B. So my upper quartile is 100, so my lower quartile is what? 40. Oh, it's 42. So quickly do 100 minus 42. Have you guys ever learned this trick? Let me show you a trick. Okay, if I had 100 minus 42, okay, if I take one away from each one, so I said 99 minus 41, it makes it way easier so I don't have to borrow and carry, and I still get the same number. What? Did I just blow your mind? Because it's the same amount, right? You take one from that one and one from that one, and it's still the same amount. Okay, so let's try it. So if I had like 100 minus 89, instead of putting, what did you say? I know, right? Okay, if I took 100 minus 89, okay, instead of having to borrow, all I have to do is subtract one from here and subtract one from here, and I get 99 minus 88, and that makes it so much easier. Whoa! 58. So, yeah, you can use that trick if you're subtracting. It makes it so much easier than having to borrow from zeros. Okay. The interquartile range for store B is 58. Okay. So store A has a greater what? Range. Because my range here is 126 and here it's 90. And store B has a greater. Here we go. We gotta write it in. Enter. Yep, write the whole thing. Quartile range. Okay. All right, here we go. Find the range and interquartile range of the data in the box plot. Okay, so what is my range? It's my highest number, which is what? 29. Let's go 15, 16, 17, 18, 19. And 5, 6, 7. What's 19 minus 7? 12. So my range is 12. Now the interquartile range, my upper quartile, which is this one, which is 15, minus my lower quartile, which is 10, 11, 12. And what do I get? 3. So my interquartile range is 3. Mean absolute deviation for number 2. So first we need to find our mean. So let's put in our calculator 16 plus 18 plus 18 plus 20 plus 17 plus 20 plus 18 plus 17. And then we divide by 1, 2, 3, 4, 5, 6, 7, and 8. So divide that number by 8, and what do you get? What? 18? So my mean is 18. Am I done? No, now I have to find the distance between. So let's put it under each number so we don't get them mixed up. What's the difference between 18 and 16? 18 and 18? 18 and 18? 20 and 18? 17 and 18? 20 and 18? 18 and 18? 17 and 18? Okay, now let's add those up. 2, 4, 5, 6, 7, 8. And then divide 8 by, what was our number? 8. What do I get? 1. So my mean absolute deviation is 1. That means the distance, the average distance in between those numbers is 1. Okay, let's find the mean absolute deviation for these. So put in your calculator, 68 plus 60 plus 52 plus 40 plus 64 plus 40. What do you get? And then divide by 1, 2, 3, 4, 5, and 6. What do you get? Okay, so my mean is 54. Okay, what's the difference between 54 and 68? 14. 60 and 54. 52 and 54. 40 and 54. 64 and 54. 10 and 40 and 54. Okay, now add those together. 14 plus 6 plus 2 plus 14 plus 10 plus 14. Yes, Cameron, you could do 14 times 3. Good thinking. What do you guys get? What? 60. And then divide 60 by 6, and what do I get? 10. So the difference in between those numbers, the average distance is 10. Right, range of the data. Now this is pretty easy. So I'm going to look here. My highest is what? 56. Okay, and then my lowest is, what do you think? What? 32.
Yeah.
I think you're right. 32. So what's 56 minus 32? 24. So my range is 24. Now my interquartile range is this, my upper and lower quartile. So that would be maybe 52. And 36. Okay, do 52 minus 36. 16. So my interquartile range is 16. Okay, those are fairly easy. You've been subtracting 1.